So what's the purpose of finding the leading coefficient and the degree of a polynomial? Well, the reason why we need to find these is both of these things are going to help us determine the end behavior of the polynomial. So the end behavior is what happens on the graph when we're ending. So in other words, are my arrows both going to be going up? Are they possibly both going to be going down, like our parabolas? Or could they be more like cubic functions, one going up and one going down type of thing? Are they, in other words, are they going in opposite directions? And which directions are they going? That's what the end behaviors are meaning, and our leading coefficient combined with our degree is going to help us determine these. So think about our quadratic functions, our parabolas. So our parabolas were even, they had a degree of 2. So if our degree is even, so that means 2, 4, 6, 8, that type of thing, our end behaviors are going to go in the same direction, just like our quadratics. So that means they're both either going to go up or they're both going to be going down. Now the leading coefficient is going to tell us which direction they're going. Remember, our A value told us if we were opening up or opening down for our parabola. That's our leading coefficient. If it is positive, we're opening up. If our leading coefficient is negative, we're opening down. And it's going to be the same way no matter if it's a degree of 4, 8, 6, 10, 12, anything like that. We're going to have these same end behaviors. Now I'm going to tell you a little bit. Your leading coefficient is always going to tell you what's happening on this right side of your graph. So if your leading coefficient is positive, you're always going to end on a positive note on the right side. If your leading coefficient is negative, you're always going to end on a negative note on the right-hand side. And then you're going to decide what's happening on the left-hand side. Now, some of the time you will also see this written as x approaches negative infinity, f of x approaches positive infinity. That means as x is going off to the left, your y value is going up. As x approaches positive infinity, over here, going off to the right, f of x is approaching positive infinity as well. That is if they are the same direction. Notice positive, 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 that sort of thing. Okay? Over here, they're both going down, so as x approaches negative infinity on the left-hand side, this negative infinity, I'm going to tell you, is talking about the left side. Your f of x is approaching negative infinity. It's going down. As x approaches positive infinity, your right side, f of x is also approaching negative infinity because it's going down. Now let's look at whenever our degree is odd. What happens whenever our degree is odd, it looks more like that cubic function. So our cubic function would come in here and kind of go like this, where we're going in the opposite directions, okay? So if our degree is odd, 1, 3, 5, any of those, they go in opposite directions. And again, our leading coefficient is going to tell us what is happening on the right side of our graph. So if I think about the right side of my graph, it's going to be going up if my leading coefficient is positive. If my leading coefficient is negative, it's going to be going down. And then I'm going in opposite directions. So that means the right side of my graph is going in the opposite direction from the left side of my graph. I'm sorry, my left side of my graph is going the opposite direction of my right side. So the sign here is always telling me what's happening on the right side of my graph. And so then, as x approaches negative infinity, that means on the left side of my graph, f of x also approaches negative infinity. As x approaches positive infinity, f of x approaches positive infinity. If your leading coefficient is positive, the right side of your graph will be positive. As x approaches negative infinity, f of x approaches positive infinity. As x approaches positive infinity, f of x approaches negative infinity. If your leading coefficient is negative, the right side of your graph will be negative. We're going to put all of this together to graph these and everything else in just a little bit in some other videos. But right now we're just trying to get the basics down. So in the next video we're going to actually look at some examples.